Hey there and welcome. Today we're going to graph absolute value equations using a table of values. Let's go ahead and get started. Alright, so the first equation that we have today is f of x equals the absolute value of x. And remember that f of x is just a fancy version of y. So f of x, y, they're the same exact thing. So when we go to graph this, if we're not given a set of values to use for x, we get to choose our own. In general, we want to have about 5 points to see what the graph is really doing, and if possible, we want 2 positives, 2 negatives, and a 0. So for my values of x, I'm going to choose -2, -1, 0, 1, and 2. And this is just going to allow me to see what's really happening with the graph. So if I plug in -2 for x, right, I'm going to say that I have the absolute value of -2, which we know is just +2. So my ordered pair for this point is -2, +2. I'm just going to go ahead and draw that dot right there. All right, my next one, -1. Again, if I plug that in for x, I'm going to have the absolute value of -1, and the absolute value of -1 is just +1. So again, I'm going to draw my dot. All right, 0. The absolute value of 0 is just 0. So this point is at 0, 0. If I plug in 1, I have the absolute value of 1. Remember, when we take the absolute value, our answer is positive. It does not become -1. It's still a +1. And when I plug in 2, I get 2. So this is about what my graph is going to look like. I'm going to go ahead, connect my dots, continue the line with arrows, and we can see that the shape of our absolute value graph makes a V. Now, what's super important for us to also know is that this purple point here at 0, 0 is called the vertex. It is not called the vertex because it's located at 0, 0. It is actually called the vertex because it is the point where our graph changes direction. So anytime we have a graph from here on out where it changes its direction, it starts going a different way, that's going to be the point called the vertex. So let's go ahead and do another problem. All right, so this time we have that f of x equals the absolute value of x minus 3. And again, we're given the points, we get to choose which points we use. So I'm again going to use -2, -1, 0, 1, and 2. They're just great points to use to start with to see what's actually happening. So if I take the absolute value of -2 and I subtract 3, well, the absolute value of -2 is +2. Minus 3 gives me -1. So this point here is at -2, -1. All right, if I have -1, I'm going to have the absolute value of -1 minus 3, which becomes +1 minus 3, which is -2. So this point is at -1, -2. I'm going to follow the same procedure for my other 3 points. All right, once I have all of those dots placed, I'm going to connect my dots, continue the line, and put in my arrows. And this time we can see that our vertex is no longer at our origin. It's now slightly slower down. So again, your vertex is just the point where it changes direction. It does not mean that it's at the origin. Let's look at another one. All right, so this time we have f of x equals the absolute value of x minus 3, where everything's inside the absolute value. Again, you can choose whatever values you want for x. All right, we can choose -4, -2, 0, 2, and then +4. We can absolutely choose these points. There are points. So let's see what happens if we choose these ones. If I choose -4, I'm going to have the absolute value of -4 minus 3, which is the absolute value of -7. And the absolute value of -7 gives me +7. So this ordered pair is at -4, 7. If we plug in -2 for x, I have the absolute value of -2 minus 3, which gives me the absolute value of -5. The absolute value of -5 is +5, so this point is at -2, 5. When we plug in 0, I have 0 minus 3, which gives me the absolute value of negative 3, which is just positive 3. All right, so if we look at what we have now, we can see that there's some point where our graph probably changes direction, but we didn't actually graph it because we didn't actually find that point because this time we skipped spots. That's okay. We just need to actually calculate where x is 3. We need to find that spot because that's really looking like that's probably where our vertex is. So let's actually take a moment and calculate that out. And I'm just going to add 3 down here at the bottom of my table. That's fine. So if the absolute value of 3 minus 3, just the absolute value of 0, which we know is just 0. So that dot's going to go right there. So now I can actually see where my vertex is and where that point is that starts changing its direction. So I'm going to now connect all of those dots. I've got my V-shaped graph, so we're all good. Let's go ahead and look at another one. All right, this time I have f of x equals negative the absolute value of x. And I'm just going to go back to my negative 2, negative 1, 0, 1, and 2. But you can choose whatever points you want. All right, so this time the negative is on the outside of the absolute value. So I have negative absolute value of negative 2. The absolute value of negative 2 is positive 2, but then we have that negative on the outside, which is going to actually keep that answer as a negative. So I'm going to go to negative 2, and draw that first dot. All right, again, we have negative, the absolute value of negative 1. The absolute value of negative 1 is positive 1, but then that negative on the outside gives us negative 1. The absolute value of 0 is 0. Even with the negative on the outside, it's still just going to be 0. 0 is not positive or negative. It's just 0. The absolute value of 1 is 1. We have that negative on the outside, so that gives us a negative 1. And our last one, negative absolute value of 2. The absolute value of 2 is positive 2. Make that negative because that negative is out front. And that's where we're at. We're going to connect our dots, draw some arrows, and there's our graph. So this time, instead of it being a V shape, it's an upside down V. All right, we got one more. All right, so for this one, we have that f of x equals 1/2 times the absolute value of x. And while we can choose any points that we want for f of x, we totally can, we also need to remember that we're multiplying by a fraction. So we don't really want to use numbers that are going to give us wonky decimals. You can, it's not wrong, but I would much rather choose numbers that are divisible by 2, since that's my denominator. It's just to make life a whole lot easier for my x values. So just like in our previous example, I'm going to go by 2's. So I'm going to have negative 4, negative 2, 0, 2, and positive 4. So when I plug in that negative 4, I have 1/2 times the absolute value of negative 4, which is 1/2 times 4. And half of 4 is 2. So this point is going to be at negative 4, positive 2. All right, so again, I have 1/2 times the absolute value of negative 2, which becomes 1/2 times positive 2, and half of 2 is 1. So this point is at negative 2, 1. I'm going to do that same thing for the rest of these points. All right, and then once I have all of those points, I'm going to go ahead, connect my dots, draw my arrows, and I can see that this time my V is getting a lot wider, but it's still in that V shape. And that really does it. We've now graphed a whole bunch of absolute value equations using a table of values. So until next time, I will see you later. Love you, bye.